Welcome to one and all. We are the students of Meenakshi Sundararajan Engineering College. We have been working on the University Admit Eligibility Predictor under the Mentorship of IBM Employees. I would like to introduce my team on the moment. We are a team of 4 students. I am Chandan Kumar. There are 3 other friends of mine working on the project. That is Prem, Akash, and Naveen. I will be explaining the problem set of the project. The problem that majority of the graduates currently face is they are either overexcited on the degree and keep over expecting they would get post graduation regardless of marks, or careless about the results and worry later that they could have studied well. So we are introducing a University Admit Eligibility Predictor where the students will be able to predict the possibility of admissions in the university based on the GRE scores, TOEFL score, and various factors based on their undergraduate performance. Next will be explained by the Akash.
Thank you, Chandan. That was a nice great introduction. Myself, Akash. Yeah, let's see proposed solution and technical architecture section here. Yeah, proposed solution. The solution we are proposing is that we are creating a machine learning model and deploying it in cloud in such a way that it is accessed from anywhere and anytime. This model will be then accessed by application, which is developed on Python, and which will provide the information given by the user. On successfully predicting the results, it will be returned to the application, and the application will be displayed as a result to the user itself. And let's see a technical solution here. We using IBM Watson in IBM Watson machine learning. We done the project. This machine learning uses a linear regression algorithm. It's run on Watson Studio itself. For the dataset, we use the dataset as a CSV file in IBM Cloud. IBM Cloud for object storage saved for machine learning. And to join the application and the cloud connection, we used API here. And the application is formed in the Flash itself, and it is deployed on Replit. And here the emojis are used for feedbacks, which is taken from the Google Front API. And the furthermore information will be clearly explained by Naveen. Naveen, take over. Thank you.
Thank you, Akash. Myself, Naveen. This is a live demo of the project. Here is the form which contains the basic information that need to be filled, such as GRE score, TOEFL score, standard of purpose strength, letter of recommendation strength, CGPA, status of project completion, which has its own minimum and maximum values of the range specified as a holder in the input field. GRCs consist of 2 sections. One is verbal reasoning and another one is quantitative reasoning. Candidate must have scored between 130 to 170 in both the section. Expectation handling is done always is always done. In case such a GRE score out of range 260 to 340 would given a error message. It should be less than or equal to 340, or it should be greater than or equal to 260. On submission, the application is redirected to the predicted page where the IBM cloud is called via API call, and data is predicted by the model deployed in the cloud. The response of API displayed in the redirect page. It also has a feedback system from which we will getting the response from the audience regarding the acceptance of the application among users. On submission of the feedback, it will redirect our home page with a notification on the top displaying the feedback you have given. Next frame will be continuing the section.
Hi, one and all. I'll be explaining the machine learning part of the project. I'll be first reading the CSV file from the cloud storage. Then I am displaying the first few data in the head section of the CSV file, and then I am removing the unnecessary column that's called as CL number, since it's just the ordering of the data set. Next time I should be removing the missing value. Since there is no missing value, we are moving on to the next part. Here I am removing the all the outlier data which is outside of the interquartile range, and we are replacing it with a range within the interquartile range. Now we are splitting the data into input data, which is used for the machine learning to predict the Y data, which is the output data we are trying to predict. Next, we are splitting the data into training data and testing data of both the X and Y's. Next, we are building a linear regression model upon which we are training the X train and Y train, which is then tested with the X train, X test, and which gives us the Y predicted values. We are now comparing the test set of the value and the predicted value, and we compare on the similarities within the both. While evaluating the performance, we get a 87% in it while checking with R2 score, and we also evaluated the performance in similar other testing cases which are mean absolute error, which gives a 0.039%, 0.039, mean square error, which gives a 0.05%, root mean square error, which gives a 0.025 error, which is quite average. It's in fact a bit better as of the scenario now. Next, we have deployed it in the IBM cloud using the following code. Coming back to the applications scalability, it is scalable further into specific university admission eligibility using the data. If we had data consolidated as one, if you are able to separate it into individual universities, we could have developed a better model in it. And we are trying to scale it to a maximum extent of multiple countries and multiple educational institutes. In future, we are trying to implement the possibilities of showing the details of the universities and the fees collected by the universities for the better discussion with their admission possibilities. And that's from our side. Thank you.